Hello, Zimmerman with NICS, and well, formerly with the RDAV group. There's no more. So, talking about scientific visualization, basically what I'm going to do is go through a brief intro, talk the principles behind scientific viz, concepts and terms, and then I'm going to do just started demos with Visit as well as ParaView, which are two kind of the primary scientific viz tools that we use in HPC. So hopefully will be informative, and if you haven't had experience with any of these tools, to kind of get started with them. So for scientific viz, I'd like to use this quote by famous computer scientist Richard Hammond, who said, "Computing is insight, not numbers." So the paradigm of scientific viz is to gain insight into the data, where you have to just, the raw data of all these numbers, and you need to get something visual to gain insight from it. A few clarifications here as being different from other kinds of you probably have info viz. Basically, the publications or newspapers will see these kind of infographics, pie charts, bar graphs, these kind of word clouds that I show on here. Becoming quite popular now, especially with a lot of the new web tools and frameworks to create these. It's kind of a different tack than scientific viz. Here you're usually dealing with most 2D graphics and more just scale values, not really going further than that. People refer to it as statistical graphs too, or statistical graphics. It's distinguished from that, and it's also distinguished from just plain like computer graphics. There we're usually referring to kind of the nuts and bolts of how you actually get pixels on the screen. Kind of linear algebra stuff, matrices, viewports, perspective, clipping, stuff that goes into actually getting the pixel. We're not going to go that in depth. Scientific viz is kind of in between these two. A little more complicated than info viz, and a little higher than the low-level computer graphics. So sources for what we call scientific data, of course, come from many different source simulations, actual physical experiments, just options, readings from instruments, etc. And so what's showing on this slide is kind of the progression of the data to a more complex view. The simple be down to the bare bones, actual zeros, the bit, bytes. Move towards standard data like floats or doubles into arrays, and then move into scalars, vectors, meshes, and then as you get high level, you kind of get more abstract from the data. You're talking about whole atoms or entire material. So kind of the goal of it is to let the science of their data at this high level, where I say I want to see this material or columns can be this low level stuff. And what the scientist software was able to do is work through this whole array of data and let the scientists be able to do more data they know how to in the domain. And I'll talk about scientific data. There's a ton of different formats that we'll run into. I'll show you when I visit or ParaView here in a minute that how many different inputs it can take as far as formats. Here's just small sampling. You've probably heard of some of these. Others may not be so familiar. More common F5 and FPDF, which are kind of general would encapsulate data. There's specific ones that have to do with particular scientific domains such as ENSO, with astrophysics. Where's the other one? PDB has to do with molecular structures. So they all their pluses and minuses, and you have to do some kind of data transformation when you're dealing with all these different apps to get them into something you can use in your biz program. Here we'll be talking mainly using Silo, which is a more general form, and also VOV. I'll talk a little bit about that. How you don't have a standard format for your data, and you can easily get it into one to be used by these programs. And the data structure. So when you're dealing with big data, you're dealing with the design structure of what the data represents. And usually we refer to that as a mesh. Different ideas with meshes. It can be multiple dimensions. Usually we just think of meshes in 3D space, but you could have fourth dimension of time, or you can get into higher dimensions if you're looking at different kinds of simulations that allow. And meshes could be implicit or explicit. That is, they could units for the meshes could actually be given as part of the data, or they should be understood to be a kind of a grid. And with the grids can be regular or maybe unstructured. Also, the idea of blocking a mesh into blocks to be read in parallel. And then AMR is a more advanced concept, stands for adaptive mesh alignment. So with that, various levels of solution in one mesh that you can access. On top of the mesh structure of your data, you would have your variables, which are your actual data values. And they can be scalars, which are just single values, vectors, which have a direction to the values, tensors, which would get into more dimensional data. I'll do this slide in there just to kind of show a difference of two things that you see in these viz programs, starting with the mesh. So the one the points are on the inners of the grid, so on the vertex points. So in one square, you will have a different data value, and therefore in the area you kind of have to purple, so you smooth the radiation from blue to white or whatever color it looks like to you, maybe blue. Whereas on with the zonal, there were for each block we're using that as one value. So and maybe the four values at the corners are average to get one value for that zone. This needs, you might want to look at it in both, either way, nodal or zonal. It's just a distinguishing factor of when you're dealing with data on a mesh. So different kinds of visualization that we'll run into with these programs. Mesh visualization is just looking at this underlying structure, just looking at actual mesh. Okay, so that's what you're concerned with, such as with molecular structure, which is shown here. Actual structure is the viz. Have added values of what the molecules are or what the chemicals are and whatnot. Scalation is dealing with scale, which just means for each point on the mesh there's a single value. And these different varieties. So the top left, kind of a 2D plot, a lot of geographic data. But this is showing actual species distribution in the Smoky Mountains National Park. Value your grid of your 2D grid, you have a single value mapped to a color, and therefore you get deal with your data values on the in structures. You have on the bottom here dealing with contours or isocontours or where you connect all the values for all the points to the same value. go ahead and in a minute when we get into the aspect of scalar is doing volume, where in addition to color, you're also adding opacity values. So you can have transparent layers that you can see, kind of see through to the next level, and so forth. Up from there, you have vectors, which again are not the single value, they have a direction. There's different ways to visualize these with arrows or lines here are shown to you. Then there's what's called multivariate viz, where you might be with multiple dimensions or just lots of different variables. One of the most common ways to view this type of data is what's called parallel coordinates. You can kind of see trends throughout the data, kind of follow where what's converge into an area graph. And all these methods I'm talking about will the ability to be done in visit or area. So these that we're primarily going to talk about today, these are source and freely available and very powerful, and that can do vision in parallel with very large data sets. So, of course, these aren't the only two. If you, this is just a sampling of the outlet for one of these called Nautilus. If you go to the next website, you'll see under the software listing, and then visualization topic, there'll be quite a list of different programs that do this. I find that a lot of them are specific to particular domains. Like I said earlier, in this case, the one on the bottom, YT, is one that's like astrophysics. It's kind of geared towards that kind of data using those AMR meshes that I mentioned earlier. Where the ones will be more general, like the ones we're going to talk about today, ParaView and Visit, which can handle full data formats and do viz across all domains. So more specifically about Visit right now, a lot of the stuff equally as to ParaView, although I'm kind of concentrating on Visit I'm familiar with. But I will show both demos today. I said it's open source, freely available. It uses VPK, which is Visualization Toolkit. That's the underlying Viz framework that Visit is built on. Well, ParaView uses the same underlying structure, the VPK. And Q is just kind of the framework to get the actual GUI, and it's tied in with Python. It makes it very powerful as well. ParaView is this connection with Python, because that allows it to be scriptable. And once you come up with visualizations that you like in the GUI, you're able to kind of split it out and run them in batch mode, which I'll show an example of as well. And I think I've already covered some of these other points. Support different file formats and parallel. And also, it's always in active development. It's come out with a new version of the model. It seems just concepts here as we did it showing the program. Again, you have the data being on a mesh. So you have some meshes like rectilinear, curvilinear, unstructured, etc. Another list of some file formats, just kind of put in categories. We'll get more into those as we look at some data. So there's two ideas that you want to kind of when you're using these programs. The one is the idea of the kind of what you're going to do, and then the idea of operators. Well, in Visit they're called operators, and ParaView likes to call them filters, but that's kind of one and the same thing. So the or how data is going to be represented in the format, and then operators are what you then add to that, kind of filter the data, threshold the data, come out, those kind of things. This slide shows many of the representative kinds of plots you can do. Already show these doing isocontours or molecular vectors, parallel coordinates, volume visualization, and even the more, the basic kind of 2D info viz kind of graphics like diagrams, bar charts, and that kind of thing. Into more things like slicing, clipping, taking tours, threshold, elevated data. So this is where you're going to take your original data and you're going to apply it, and then your resulting kind of subset of the data then is whatever plot you choose. And then there are capabilities of data analysis in this tool as well, like big specific values, even looking at the spreadsheet kind of view, or making line charts, do queries, and the primary benefit of using these tools in the HPC environment is that you have a very large data. So whereas these tools you can run them on your laptop, okay, you go run them on a supercomputer, large volumes of data, while still on your laptop. I'll show you how to. Here's just itself. It's actually 4 different programs together, so that will confuse you when you try to run it. But you'll realize there's the GUI part, which is kind of all the controls of what you're seeing. The actual viz window, which is called the viewer, that's where you see your plot. But then behind the scenes, there's the database server as well as the computing engine. And so this way is to allow the kind of HTML of you can run GUI and the viewer on the laptop, whereas the database server and computing engine you run supercomputer. You can have multiple server architecture, which is popular with this kind of viz tool. The same thing applies to parity. Okay, so switch gears and open a visit and just kind of walk through some basic options that you might do. So again, freely available if you go to the visit website, you see the latest and visit used to be kind of a bear to get going on the laptop. They've made it quite a bit easier now with newer versions. Installers for Mac, Windows, same. So you should just download it fairly quickly. So the visit when you open it up, and again, the different parts I was talking about. The big blank screen is your viewer running, and then your GUI is actually a separate process over here with controls. We're going to open up a file that's over on the top left. It's the open icon. And here, the very first thing that asks is the host. This is where you can part of another machine. I'll do a description of that later. There you'll see our machine go through Kraken, Garter, Nautilus, etc. Now we're just using localhost because we're running everything locally. I'm just going to choose a file. Your key image of a conglomeration of a bunch of CP image files that we're going to look at. Bottom where it says open file. If you click, here's just an idea of how many different formats you can take in. You'll see that the limit on and on. So all the images or all the formats that are out there. Of course, there's going to be some that are you can usually tweak them into one of these formats. We're just going to say guess the file name from the extension, which it usually does automatically. In this case, this file is a silo file. It ends with silo. So we'll go So you'll notice when you're using these programs, they don't seem very good. And you might do a thing like here, we opened a file and nothing really happened. That can be kind of frustrating to the user. They find it, which I'll get. So for now, just simply look at the metadata for the file. So here at the top menu, there's something that says file information. You see that all the information from the file tells you the mesh in there with 27 blocks, etc. Tells you the data reader that used to read it in. The file format is silo 1.0, and it tells you variables are in there as well. Now we just have single. So earlier, the first thing you want to do is decide, how do you want to see this data? What kind of plot are we going to use? So the add button to the left, you'll see a different plot types. We're going to one called pseudo color. The drop down of the available part of this, in this case, is called head. We'll pick that and then draw. That was probably too quick to see, so notice there's a color change. When we first pick this color over here in the list, which means it's ready to be rendered. We render it automatically, and again, it goes back to the thing that it doesn't seem very responsive. You'll make a change and you won't see anything unless you click apply or click draw. The reason it does that is it's designed to deal with very large data. So a lot of times, one change you make will, underneath the hood, will be a lot of computing, a lot of things have to do. You want to make sure that you're doing the right thing. Kind of exploits that you have. About colors, it appears in green, which means it's ready to draw. As soon as I can draw, you'll see it change to yellow, which means computing, and it'll change to black or white. An image of this data set doesn't do much. Of course, drag it around and see that it's a 3D of some sort, but most color because we're not seeing the data that's kind of inside this block. We're actually looking at the bottom here of the spinal cord on this one side, kind of an indication of one part of the data. So what we want to do is take us through this data to kind of get an idea of what's inside. And talking about the name of this plot called pseudo-color, just for the reason it's not actually using color information that's in the data. The data is purely, scalar value to the point. So what does it take those values and map them to a particular color? And you see them in the color spectrum used here from the values a little bit, go from 0 to 1. So then there's applying these operators. So we picked our plot, and then we're going to add some operators to it. In this case, we're going to pick, so that's under the slicing category. And again, stuff usually happens. So on the left, if you click the down arrow, you'll see what got selected so far. So there's the pseudo-color plot. We just had it sliced. We haven't really, how to do this slicing. So in this, double-clicked on the word slicer, and hit any operator you're using. So just you can set here, set the z-axis, values a percentage, and say 50%. That way we get a slice halfway through the image, and click apply. Click draw again. So you get a 2D image, with just one slice through the 3D. So you get the idea all here that's inside. There's still a let's end with the 3D model. So we could go slice attribute 2D and turn off and where the slice actually fits in with the 3D volume. More story kind of bit, you can choose up here at the top what's called the plane tool, and then some kind of handles, so you can move it around. Sometimes range of the data. Through the data set, you can also table slots, an idea of looking at that. Another even quicker way to go about this is kind of slice. There's a piece which takes 3 uses at a time. We could go even this point. Draw again, and then you can easily see you got an idea of each direction, what the looks like. So a few more operators and how they work and visit and things you can do. Another popular one to use is called volume. So let's do isosurface. So surface, what the underlying compute model is, I go through all the data sets, you give it a number or a particular data value, and it finds all with that value, and in a sense mesh according to it. So let's get the value of say 2 on the data. If we draw that, so now so the range of values in the CT scan, you can tell the lower value is close to 0, which we picked 0.2. It's close to the layer of the skin. So get almost the whole image of the head here. If we go further and pick the 24, let's say, then the bone layer, which is has a different density value around 24. So this is a way to look at your data. I want to do on those operators add maybe a clip. So we want part of the data out. Oops, I missed something there. Forgot to use. So a lot of this trial and error when you're doing viz like this, it's a sometimes to get what you want out of it. I have a clip through the top part. As we've done this on the left here, we've built up what's called the pipeline. So there's the idea of initial data. First you do this operation, then you do the next, and then finally you render it. So here you see the progression of first we did the isosurface, then the color, then the color at the end. So programs, there's this idea of a pipeline, and which can be done in parallel with large data. Kind of over here, so I'm going to switch, we'll get rid of the whole thing. The volume. This is kind of using the default code that looks pretty bad. It's kind of a fuzzy blob. But volume plot is, in addition to color setting, you also have an opacity. So you can do some real nice things with transparency and kind of through the data set. Get an idea of what the kind of things here you can do with volume plots. I'll just show a few that you can use up the number of samples quite a bit to get a solution. 500. Around with this, you'll start to get the limits. If you make these numbers really high, you'll bog down your machine if you're using a single laptop. This one is a little bit longer, and then it renders, so it has quite a bit more work there, figuring out the opacity values. But here you can see the skin layer, which is very transparent, and also the skeletal structure as well. So there's kind of there's also when you're dealing with plots, is what's the function. And this is just what maps the colors to the values. So you can mess around with color values and also the opacity values. Like here, these are just, you can drag a curve and values you want to see. That doesn't change that much. Let me take our lower values. You can see quite a while to really, come along with something that you would leave with the visualization. So at this point, let me show you would say something in visit. So there's different options. If you go under File, you can do session, which is very nice. If you've done whole operators and you've made all the settings, and all this looks great. How do I save it? You just save, and that saves all the information you've done, settings, as well as the resulting image. And then when you visit again, you just load that session and you're back where you started, where you can start where you left off. On the single image, you can do which you need to go to save options, and then you can file type. It supports various file types and resolution as well. Kind of stuff. I'm kind of trying to make this a brief overview of just some of the things you can do. You'll notice playback controls here as part of the GUI. So a lot with data set timers, so you have just at particular time steps. If you have that kind of file, you can play them as a movie here in Visit and record them out as a movie as well. Okay, so now I will show Visit. And some of the same things I just did in Visit and Imperative, just to give you an idea of the comparison. So really there's a lot of difference in two software, Visit and Imperative. They both have things, they do them a little differently. You'll pluses and minuses both ways. Imperative opinion kind of has a nicer layout, kind of easier to get started with. If you just this one single window, and it's got nice icons kind of for all the operators that you're going to do. So just briefly here, I'll go through the same kind of work I did with Visit. File, and one file formats varied, and just somehow got this. So you can read into, you can read, so it just kind of borrowed all of Visit's code for that. The same as CD here. So you see the pipeline, actually call it the pipeline browser. And then properties down here that applies like we saw in Visit. So let's take an extra step here. Once we load in the data, you want to tell it, okay, what out of this data set do I want to see? Visit just kind of throws it up there for you. Here we're going to select our variable down here, click apply. This is you kind kind of the mesh. And what Visit didn't show you is that this mesh is divided into blocks. So 20 different blocks here. And the reason is when we get into parallel runs with the data, each core could work on one block of the data, and they can do that in parallel. And you can get effective very quickly. So here shows you what's going on behind the down here, it's kind of hard to see with these squash windows. We do the same thing up here at the top of the GUI. Select what representation you want. Right now it's on outline. If we pick a surface, now in kind of blank cube, there's not any of the data until we pick the variable over here for the color. So we're going to head, and then you'll see the same thing on one of these sides. So the end of the TT scan there. So with this, a lot of the things operators are called focus. A lot of them easy to get to right here at the top. You've got your options for contour, clip, slice, threshold, and other ones. Also make it to there's a nice search feature. So, you kind of know the name that there's something called, maybe about that. There's something, called slice. You can start and see, it's slice. It's got some other ones too. So, when you're ready to go. So, and it also gives you some tools. Whereas Visit, you had to explicitly pick them. Do the slice tool before you can see it. You know the data set where you want. Change the angle here if you want. And then it doesn't show you click apply. And then you see it. So, same did with Visit. We saw a little. What I wanted is one of the more powerful features is the use of Python tools. I'm going to now go back to this for a second. There's these different modes of running the program. Doing the whole thing on my laptop with the viewer. So your flow is that people initially with their data, they get what they want to see. They might save out an image or two. And then what the Python equivalent of what they do in the GUI is. I'll show you how to do that in a second. Script. In batch. So say they found a good way to visualize a certain data set that they want to take maybe 1,000 images through 1,000 different maybe slide data. They can write a script that does that, apply it in batch, and they can just run it all in the background and output the images without even using the GUI part. So I'm going to open up that file again. Show this with a lot of sample data. We'll use this one. Is basically just a random data set, but it's good for demonstration purposes. So again, we'll do a color plot, which is one of the variables. Okay. Say we want to do an ISO contour, and we'll do that in Python, but we don't know how to do it. What I need to do is up here in Control, Command, and Python command window. It's already pre-done scripts. Let's go to blank one. And so record, and we hit record, everything we do in the GUI is recorded, and then the Python equivalent. I'm going to go ahead and here. and have some other screens because it's actually running Python in the background. Visit. Okay, what we're going to do is the same thing we did before. We went under operators, went to so circle like that. Our airline, double click this, maybe put in or I put a percentage. We'll do 50% and hit apply. So there we've just our workflow included to our Python control. We hit stop recording. Now the Python that allows me to just do that. And it spits out everything, so you kind of have to pick and choose what you need. Here you can all we need is this part of contour T, and we do a call attribute, then we set it to 50, and then down here at the bottom we do that. Maybe useful this could be, let's convert this into a little script. We can take stuff. A lot of this settings we don't have to necessarily give it, we just know what to do. So it's just regular Python, so you can make a loop like for in range. Say we want to go to the step 5. That's what we set our contour percent to. So with the I here, I can move this line to the top. And then inside our loop, we set the contour percent. Okay, now let me get back to so we can see this a little smaller. So it'll go through the loop, setting a contour for each of these values. So we hit execute. And so it automatically contour each of those points and does the rendering. Then, once you've done something like that, you can just out and run visit even without the GUI and just give it the script, and it will automatically render these. People do this once they do like a fly through kind of idea through their data. They come out of script, it automatically generates those images, and then take that to another program like Avi or something like that to actually generate high quality from it. Okay, so about earlier, actually running your computer. I'm kind of brief how that works. So let me do this. So when we go back to say open a file, this is the same dialog here, and just under localhost by default. So now pick and it brings up the login for Nautilus. So you account here, code. Okay. So now the scene is on Nautilus. Actually, part of the physics form there, and then it will open. And as you can see, my path is I'm actually looking at my file on Nautilus. Let's see data. On my Illustrator Scratch space. So, as I talked about earlier, once you review, it's easy to come up with visit documentation has details on how to do that. If you have your simulation, whatever, spit out with raw data, it's easier than this format. Basically, you have your raw data in some files, and you have a little metadata file that tells about the structure of that. So here, the metadata file is this .vov file. The data are in these zip files. There's 8 of them here, so it's divided into 8 blocks. So we're going to read this in. Now, as soon as I click OK to read in this file, it's going to ask about the specifics of the job I want to run. I just want 8 cores for this. Out. And okay. Settings you saw right there as far as how to connect to the machine, your account name, vault cores. That can be set up in Visit in what's called a host profile. And if you download Visit on your computer, when you run it, it'll ask you which host profile you want to install. So the next, it'll give you all these for Nautilus and automatically. So, host profiles within the world. So what it's actually launching, if I look, so I have open on Nautilus. You see that I have a job running. My job, Simmerma, running 8 cores. So scenes on Nautilus is actually launched the PDF, which is going to run Visit. See, it's all just my GUI here on the wall. So behind the scenes, now it's ready. So if I add a pseudo color plot and click over here, okay, so quick. So it's in parallel. Again, this was divided into blocks already. So we had 8 pictures doing work in time, which made it quicker. And so it's helpful. I'll just go in here. You can make under. Again, there's a ton of stuff I haven't really touched on, but I'll show a few highlights. You can do what's expressions in Visit. So here under expressions, which are your own variables based on other variables in the data. One already takes, this is kind of inside trick you can do using this proc ID function hash of your data, which is called mesh. And we'll turn the processor number that you have is so we use this over here on the color. I'm going to switch the variable from looking at this one called Hardy Global, which is what we were looking at. I'm going to switch this prop variable which I created. And now it's based on what processor is running your data. So this is a way to kind of check, do a sanity check and make sure that it's like it should be, and all the processors are running each block of this. I think to show as far as Visit and pair view, any questions that there might be at this point?